Ladies and jelly beans, the past couple of videos have been talking about models and diagrams that show multiplying fractions. Today, we're going to get a little bit more into the meat of the problem. Not that diagrams are not a good way or a right way to show multiplying fractions, but I'm going to show you some more numeric ways, which is the goal for today's lesson. And so I have a bit of a problem. Not really that big a problem. But the average person is given 24 hours in a day. I suppose that the above average or below average person also gets 24 hours in a day, but of those 24 hours, this person spends a third of that time sleeping. And then of that time, of that third of this time, they spend a quarter of that time dreaming. So my question is, what fraction of the person's total day is spent dreaming? And then what about when the person is asleep but not dreaming? So you will notice I have this lovely little diagram drawn out here. And so this blue section here, well, this blanket basically represents a person's whole day. And so this blanket represents 24 hours. Now, these, there are 12 squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Of these 12 squares, fully 8 of them are spent awake. And this section here represents that third of the time that a person is sleeping. Then of that third of a time, this last little square here represents the time that the person is dreaming. Now last time we looked at these grids and shading stuff in. And so we're looking at a problem that's like it's a quarter of a third, which is what I want to know about. Now, it's nice that this diagram's already all drawn out. There are 12 sections here, and of those, one of those 12 is spent asleep and dreaming. Okay, so that answers the first part of the question, asleep and dreaming. And 1/4 can be rewritten, can be rewritten as a time symbol, so it's 1/12. And my other part that I'm curious about is that part that the person is asleep but not dreaming. And if I look here, it's 3 out of those 12 sections. So 3/12 of your time, which can simplify down. So it's a quarter of your sleep time is spent asleep but not dreaming. That's out of the total day. And out of a total day, 1/12 of your time is spent asleep and dreaming. Okay. Now that sort of gets me to the next part, where we're actually going to start looking at some examples of multiplying fractions. When you multiply fractions, there's kind of a rule that we follow. If we think back to addition and subtraction, the rule that we were following was to find a common denominator and add or subtract the numerators. With multiplication, the rule is that we multiply the numerators together and that we multiply the denominators together. So if we have a question like half times, it's 1 times 2, numerator times numerator, and then 2 times 3, which is denominator times denominator. So 1 times 2 is 2, 2 times 3 is 6, and that's the answer. It's not necessarily in the simplest form, because you have to simplify it down, but that just means that's 1/3. So 1/2 times 2/3 is a third. Okay, numerator times numerator, denominator times denominator. So if we have some problems here to work on, we have 3/5 times a half. 3 times 1 is 3. 5 times 2 is 10. That's it. That's the answer. Okay. It's already in the simplest form because 3 is a prime number. Here we have 3/4 times 5. And don't let that throw you for a loop. Anytime you see a whole number, you can rewrite that whole number as the number over 1. So leave 5 where it is, put it over 1, leave whatever the whole number is, make it in your numerator, and then put it over 1. Okay, so what happens is they end up with 3 times 5 is 15, and 4 times 1 is 4. Now we have an improper fraction we have to convert. 4 goes into 15 3 times with 3 left over, so it's 3 3/4. Over here we have 5/6 times 2/3. 5 times 2 is 10. 6 times 3 is 18. Okay, numerator times numerator, denominator times denominator. Divide by the greatest common factor, so it's 2 for each, so it becomes 5/9. Okay, lastly, 1/5 times 3/5. 1 times 3 is 3, 5 times 5 is 25. Okay, now just because the denominators are the same here, don't be tempted to just leave them alone. You still have to multiply them. Numerator times numerator, denominator times denominator.